All right, hello guys, and we are in week 7 statistics, lesson 10.1 scatter plots and correlation trend lines as well. So for this week, there was kind of a lot that we needed to go over last week, but in terms of this week, um, I thought we'd do something a little different and talk a little bit more about some of the applications of what we've been learning. So, for example, two variable data is a collection of paired variable values, such as a series of measurements of air temperatures at different times of the day. So, what that means is in statistics, for a lot of the stuff, we take two variables and we compare them to each other, and we see if there's any kind of relationship between them, right? So, for example, hot days, right? And ice cream sales, right? So, generally speaking, the hotter that there is a what we call a correlation between hot days, the hotter the day gets, the more ice cream that tends to sell, right? Um, and the correlation tends to work one way. What that means is there is a relationship between those two things, between the temperature and the amount of ice cream sold. However, we can't confuse this with this correlation with causation. Causation means one thing happens because of the other thing, right? So, for example, you, we could, I guess, make a claim that yes, there is a correlation between the amount of ice cream, right, that gets sold in a day and the temperature. The higher the temperature, the more people are going to want to buy ice cream. There's a relationship there, but that doesn't mean that one causes the other. It's true. A good way of thinking about this is what happens if you reverse that. If there really was a causation, we'd be able to see uh, one thing causes another. But here, what we have here is if we reverse that, the relationship doesn't work, right? So if we say, okay, um, I sold a lot of ice cream today, does that mean that the more ice cream I sell, the hotter the temperature is going to get, right? So let me just give you an example of what I mean by, when I'm doing this basic graph. This is going to be just the temperature. And this is ice cream sales. And then there's a line like this, right? Now, what this is saying is right, the more ice cream we sell, the higher, um, the higher the temperature. There is a relationship between these two, but it only really works one way. There is what we call um, a positive correlation, or in other words, it's a positive relationship. That means that the line is going up, right? The line is going up because it starts near the zero, right? It goes onto here. It starts at zero, and then it goes up. The more it goes to the right, the higher it goes, right? There's a positive correlation between high temperatures and ice cream sales. However, the relationship doesn't work the other way, right? Like I said, I can't say that if I'm walking around and I'm selling ice cream, just because I'm selling a lot of ice cream doesn't mean that that will make the temperature go up, right? So the relationship only really works one way. And again, it doesn't cause the other thing. The temperature can go up and it can go down. Every day the temperature goes up, right? Like in the morning it's cold and then the temperature goes up in the middle of the day and then it comes down again. Well, what if, you know, I was in a place that just didn't have any ice creams to sell? The temperature's still gonna go up, right? But no ice creams are going to get sold if I don't have any ice creams, right? So one thing doesn't necessarily cause another. I'm just saying that there is one specific relationship going one way, right, between these two variables, and That is the concept behind a correlation, and that's what we're going to be doing, right? Okay, a scatter plot is just a method of visualizing the two variables plotting along each axis. The way that we get that line that I'm talking about is we basically take a bunch of data points, a bunch of coordinate points, right? And they're going to be doing this, right? Just a bunch of coordinate points like this, right? And there's a line that's they're in general they're kind of going up, right? As the points move more to the right, they go higher and higher in general, and this is what we call a trend, right? Now this is what we call a scatter plot. This type of graph that I just showed you is a scatter plot, and it's a way of comparing these two variables. Okay, now what I have in front of me here are the different types of correlations and R values and their graphs. Now you might be thinking, what's an R value? Well, remember when I said that um, in order for us to have what's it called, these graphs, we need a bunch of coordinate points, right? So if there's a very long, complicated um, calculation to find something called an R value, and the R value just tells us how strong the correlation is, right? On the bottom here, I don't know if you guys can see it right here. I meant what the R value means in terms of correlation, right? If you determine that a graph has a strong negative correlation, it has an R value of -1. If you determine that it has a weak negative correlation, it has a R value of negative 0.5. It honestly could be anything in between 0 and -1. We're going to use the midpoint. We're going to use negative 0.5 just because it's a little bit easier to do that, right? It's in between no correlation and strong correlation. Um, so we're going to just leave it at that, right? Uh, a positive zero point 0.5 is a weak positive correlation, and a +1 represents a strong positive correlation. In other words, the closer and closer you get to either a -1 or a +1 will tell you how strong the relationship between both variables are. Now, if you notice, I split this up into 3 sections here. Now, this section right here shows you all the possible positive correlations. Now, you see the first one, it says that it's what we call a strong positive correlation, this line. If you notice, all the coordinate points are kind of together, right? Like you see how they're all like bunched up together. And in general, the more right they go, the higher they go. All I did was I drew a dark line, right? That line is important, by the way, and you are going to have to figure out what that line is and the equation for that line later on. By later on, I mean later on this video. But I need you to first be able to identify that that is what we call a strong positive correlation, because most of the coordinate points are very, very close to that trend line, right? Uh, on the bottom, it says a weak positive correlation. Now, if you notice, there's still a general trend of the little coordinate points. They're still, the more to the right you go, the higher they're still going, right? It's still in general going up. There's like a trend that all of them are kind of going up. However, they're not as close together as the strong positive correlation. They're kind of spread out a little bit more. They're kind of wider. There's more room for error there, right? It it suggests that there is a relationship, but it's not a very strong relationship. We always want to see, most studies would prefer to see a strong positive correlation between the two things they're studying, but sometimes they find a weak positive correlation, and that can be that basically means that you're heading in the right direction, but there's something you're not considering, right? Those two variables might be related, but they might not be related in the way that you think, right? If you notice in the middle where it says no correlation, a no correlation looks like that. It looks like it's random. All the points are kind of just everywhere. They're not really going up or down. They're kind of just evenly distributed. There's absolutely no relationship between both variables that you're studying here. And again, the R value for no correlation would be 0, okay? So again, for homework and practice problems 1 through 4, you're gonna have to just tell me what R value you think it personally is, right? So if you think that in the homework and practice, they give you a graph, right? And it looks like this, you're gonna tell me, okay, I think it's a strong positive correlation, which means that the R value is gonna equal to +1. That's what I expect to see in the homework and practice that you guys are gonna do. I just wanna see those things. You're gonna see other directions for problems 1 through 4. I personally only want you to write label it correctly. Is it a strong correlation? Is it a weak correlation? Is it positive? Is it negative? And what R value corresponds to them, right? The bottom one, if you see something that looks like that, you're gonna say, okay, it's positive for sure, but it's definitely weak. It's a weak positive correlation, which means that the R value is most likely gonna be positive 0.5. If you see something that's kind of really random, like what you're seeing in the middle, you're just gonna say it's no correlation. There's no correlation, and the R is 0. The R value is 0. For the negative correlation, again, you're gonna write it's a strong negative correlation. It's going down, right? In general, they're all going down, and they're all really close together, and they're all kind of around that trend line, right? That dark line that you see that's in general going down. If you see that it's really strong, the R value is going to be -1. Whoops. Okay, -1. And over here, the R value for here is going to be -0.5, right? And then it's a weak negative correlation, right? Because they're further away from that line. There's still a general pattern of it going down. It's just not as the relationship is not as strong as a strong correlation. It's a weak negative correlation, right? Um, Before we move on, I just want to make sure that you understand this a little bit better. Let's use the ice cream example, right? Ice cream, and we found out there is a strong positive correlation between ice cream sales and the temperature, right? That would mean that every time the temperature goes up, a bunch of more ice cream gets sold, right? A lot of ice cream gets sold all at once, like you sell out kind of deal, and it happens a lot. A weak positive correlation would mean that you notice an increase of sales at the same time you notice the temperature going up, but it's not happening every single time. It's like it's kind of happening, and you notice that in general it happens, uh, but it doesn't happen every single day because of whatever, right? No correlation would mean like, no, there's no difference. Every day I kind of it just depends. Sometimes it's so a lot, sometimes it's so a little, sometimes it's hot, sometimes it's cold. It doesn't really matter. I make about the same amount of money on ice cream every single day. That would be a no correlation. That's the one in the middle. Again, the ice cream example, a negative correlation, right? Let's say that there is a negative correlation between cold temperatures and ice cream sales, right? There is a strong negative correlation, right? That means that, uh, oh, I'm sorry, I meant to say, what's it called? High temperatures and ice cream, right? There's a strong negative correlation when it comes to um, the temperature dropping, right? So if the temperature drops, ice cream sales also drops, right? And this a strong negative correlation would suggest that it happens a lot, right? That it happens all the time. Versus a weak negative correlation, you kind of notice it happens. It might happen. It's getting cold. People are not going to be craving ice cream as much, right? But you're still selling some ice cream, right? It's not like you're not selling anything. Okay, so what does this mean? Well, for the other problems in the homework, for problems 5 through 8, what you're actually going to do is you're going to do something called the line of fit problems. Remember that line that I told you about, that dark line that kind of tells you the general trend? Remember how I said you were going to have to figure out how to write an equation for that line? Well, for 5 through 8, for those 3 problems, This is what you have to do. Right? The problem will say determine the line of fit for the data and write the equation of your line. What it's asking you is to remember that dark line and that determines the direction of the correlation. The problem wants you to find the equation for that line, right? So here I have an example, right? I have a graph that's given you, and there's gonna be 2 points that are pre-picked for you. But what you're gonna have to do is you're gonna have to look at the line that they give you, and you're gonna have to kind of look and find 2 points on that. There isn't going to be necessarily a dot that's directly on that line. You're going to have to go and be like, I think I see, okay, there's nothing there, but I see that there's probably a coordinate point there. I'm going to put a coordinate there, and I'm going to use those 2 coordinate points. So for step 1, you pick 2 points that looks like they're actually on the line. You write down those coordinate points. In this case, my coordinate points are going to be 1, 2 for the first coordinate point, and 5, 5 for the second coordinate point. And if you notice, I label them x1, y1, x2, y2. The reason I label them like that is because I'm going to have to use the slope formula, right? So step 2 is use the slope formula to find the slope or the m value, right? Starting to find the slope of that line. And I'm going to do that by using these 2 points. The reason why I label them x1, y1, and x2, y2 is because the formula is right there. It's, m is equal to, or my slope is equal to y2 minus y1. Y2 is 5. That's why this became a 5 right here. Right? The other one, y1 is 2 right here. That's where I got that from. Right? And then I have x2, which is 5 again, minus my x1, which is 1. So I have 5 minus 2 is equal to 3, and then 5 minus 1 is equal to 4. So I have 3/4. My m value, my slope is 3/4. That means that from this point to that point, I rose, I ran 3. I ran to the, I'm sorry, I rose, let's see, 3. So that's 1, 2, 3. And then I ran to the right 4 times. 1, 2, 3, 4. Right? And I ended up there. That's my rise over run, which is also known as my m value, which is also known as my slope. They're all the same. Okay, so now that I have my m value, how does this help me find my equation? Well, this is part of my equation. If you're wondering how am I going to write this equation? The equation is going to look, it's going to be in this form. Y is equal to mx plus b. And if you notice, there's an m in there, and we just figured out what m is. Okay, we just need to figure out what x, y, and b is, right? So our goal is to try to figure out what b is, but we need more information, right? So we're gonna plug in one of the coordinate points. We're now in step 3 now, right? We're right here. We're gonna plug in one of the coordinate points into y equals mx plus b to find the value of b. Now again, if you notice here, I started off with the original equation down here, right? And then I plugged in my first coordinate point because it was going to be a little easier if I just did it that way. I plugged in 1 and 2 for my x and my y. So instead of my y, I replaced that with the 2. And I replaced m with what I just found out. My m, again, is 3/4. So I put 3/4 times, instead of x, I put 1, right? Because my x is 1, plus b. I don't know what b is, and I'm trying to figure out what b is. So now I'm going to have to solve this. 1 times 3/4 is just going to be 3/4. So that's why I'm down here now. 2 is equal to 3/4 plus b. Now, I got to get rid of that 3/4. Now, 3/4 is currently adding, so I'm going to subtract 3/4 from both sides. That's what I did here. I put a minus 3/4, and I put a minus 3/4, because if I subtract 3/4 from the right side of the equation, I need to subtract it from the left side of the equation. And I'm left with this right here. I'm not done, by the way, but I'm going to move on to the next page. But b is equal to 2 over 1 minus 3 over 4. When we're subtracting fractions, right, we're left with that, and we need to have the same denominator, which is why the 2 over 1, I'm going to multiply by 4 over 4. The reason is because I want them to have the same denominator, so, and I don't want to change the value. 2 over 1 times 4 over 4. 4 divided by 4 is just 1. Anything times 1 is just itself. I'm just changing the way 2 over 1 looks so that it's compatible with 3 over 4. In this case, I have 8 over 4, right? So, side note here, 2 divided by 1 is just 2, and then 8 divided by 4 is just 2. Value has not changed. Anyways, 8 over 4 minus 3 over 4 is going to equal to 5 over 4. Right? So that was step 4. Once you have the value of b, which now we know b is 5/4. By the way, it won't always be a fraction. It just kind of worked out as a fraction in this case. We're in step 4. Once you have the value of b, replug the value of m and b into the y equals mx plus b form for your final answer. I'm going to resubmit those, and I'm going to put them in there. However, this time I'm not going to put the coordinate point. Remember, I put the coordinate point in there to figure out what b was, but I'm not going to put them in for my final equation. My final equation is just going to be y is equal to, I'm going to replace m with 3/4 because we figured out that's what m was. I'm going to leave the x attached to it, plus what we now figured out what b was, 5 over 4, 5 over 4. That is step 5, write our final equation that fits the line. This is my equation for that line, right? And by the way, there's a bunch of points around this line that made this line what it was, right? There was a general weak positive correlation. This line trend was formed between those 2 points. I took those 2 points and I followed these steps and I figured out the equation that represents that trend line. Right? It's the final equation that fits the line. And that's what I want you guys to do for problems 5 through 8. Again, feel free to join me for my Zoom at 1:30 to 3 p.m. Monday through Thursday if you guys want help with this. I have practice problems 1 through 4. What is the R value and type of correlation? You're going to have to tell me, is it strong or weak, positive or negative correlation? You're going to write what it is, and then you're going to tell me, okay, I think it's, a positive, a weak positive correlation, which means that the R value is going to be either negative 0.5, positive 0.5, positive 1, a negative 1, or a 0. There's only 5 options, so you're going to just label it really easy. 5 through 8 are a little more complicated. Please contact me for my Zoom office hours at 1:30 to 3 p.m. Monday through Thursday, so I can clarify any questions. All right, have a good day.